Today we'll discuss Fourier transform and its integral. So Fourier transform of a function f is denoted by f cap omega, and the equation is 1 by root of 2 pi integral minus infinity plus infinity f of x e raised to minus I omega x dx, and its inverse is given by f of x equal to 1 by root of 2 pi integral minus infinity plus infinity f cap omega e raised to I omega x d omega. So we have Fourier transform equation is f cap omega and its inverse denoted by f of x. Now we do some problems on this based on this. First question is find the Fourier transform of f of e raised to minus ax x greater than 0. So let us we take f of x as e raised to minus ax x greater than 0. Then we have to find the Fourier transform. So Fourier transform equation is f cap omega equal to 1 by root of 2 pi integral minus infinity plus infinity f of x e raised to minus I omega x dx. Now we replace f of x with e raised to minus ax. So we will get 1 by root of 2 pi integral 0 minus infinity to so here your x is greater than 0. So instead of minus infinity plus infinity, it becomes 0 to infinity. E raised to minus ax, e raised to minus I omega x dx. So here minus is common and x is also common. So we take now outside. So e raised to minus of a plus I omega x dx. Now that is the forms of integral e raised to minus ax. So we have to integrate. So 1 by root of 2 pi e raised to minus a plus I omega x divided by minus of a plus I omega over the limit 0 to infinity. So it become minus 1 by root of 2 pi a plus I omega into, when you given the upper limit, its value will be e raised to minus infinity is 0 minus, when you given the lower limit, it is 1. So the answer is 1 minus will become plus 1 by root of 2 pi a plus I omega. And next question, find the Fourier transform of f of x equal to 1 minus x square mod x less than 1 and equal to 0 for mod x greater than 1. And also one more question, using inverse Fourier transform, show that integral 0 to infinity cos omega by 2 sin omega minus omega cos omega by omega cube d omega equal to 3 pi by 16. So first we find the Fourier transform. As usual, f cap omega equation is 1 by root of 2 pi integral minus infinity plus infinity f of x e raised to minus I omega x dx. And then replace f of x with 1 minus x square, and the function is defined in the interval mod x less than 1, that is minus 1 less than x less than 1. So the integration limit will changes to minus 1 to 1 minus x square e raised to minus I omega x dx, that is equal to 1 by root of 2 pi integral minus 1 to 1 minus x square into e raised to minus I omega x equal to e cos omega x minus I sin omega x. We have studied in schools that you have written here e raised to I theta equal to cos theta plus I sin theta. So this e raised to minus I omega x can be written as cos omega x minus I sin omega x dx. Now when you multiply 1 minus x square with the cos omega x and 1 minus x square with the I sin omega x, we get two integrals. And here 1 minus x square is an even function that I have already shown here how to get this 1 minus x square as even function. For even function, f of minus x equal to f of x, and cos omega x is also an even function. So these both are even function, whereas in the second integral 1 minus x square is even and sin omega x is an odd function. So odd into even is an odd. So the second integral part will become 0. So only we have left out is 1 by root of 2 pi minus 1 to 1. The integrand is an even function. So we can write as 2 times integral 0 to 1 minus x square cos omega x dx. That is equal to 2 by root of 2 pi. Now this is integration by parts. So 1 minus x square into cos integral sin omega x by omega minus integral of the first part 1 minus x square derivative, that is minus 2x, derivative of the first part minus 2x into integral of the second part, that is minus cos omega x by omega square, plus again integrate again differentiate to minus 2x become minus 2 into integral of the second part, that is minus sin omega x by omega cube over the limit 0 to 1. So 2 by root of 2 pi, when you given the upper limit 1, the first part 1 minus 1 0, so that term will become 0, and in the second part it will become minus 2 cos omega by omega square, and in the third part it will become minus of minus become plus 2 sin omega by omega cube. Minus, when you given the lower limit, sin 0 is 0, and in the second term 2 into 0 0, so whole term will become 0. So this is the in answer. So from this we can write as 4 by root of 2 pi, that 2 into 2, 4 by root of 2 pi sin omega minus omega cos omega by omega cube. So this is the Fourier transform. Now we have to find the inverse Fourier transform. That means you have to find f of x. So the equation is 1 by root of 2 pi integral minus infinity plus infinity f cap omega e raised to I omega x dx. And this f cap omega is replaced by this 4 by root of 2 pi sin omega minus omega cos omega by omega cube into e raised to I omega x can be written as cos omega x plus I sin omega I. Here also we are dividing into two integral forms, and the first integral again sin omega minus omega cos omega by omega cube is an even function. How it is getting an even function I have shown here in the side. Okay, and into omega cos omega and omega cos omega x is also even function. So the first integral is an even function and the second integral is an odd function. So that becomes 0. So we get 4 by 2 pi. This is, since it is an even, you can write as 2 times integral 0 to infinity sin omega minus omega cos omega by omega cube cos omega d omega. So therefore the 2 cancel, we have 4 by pi integral 0 to infinity sin omega minus omega cos omega by omega cube cos omega x dx. And in the question you can, this is your f of x, and in the question it is nothing, and you have to show that cos omega by 2. So that means x, you have to write, you have to put x equal to 1 by 2. So when x equal to 1 by 2, what about f of x? F of x is 1 minus x square. So it become 1 minus 1 by 4, that is 3 by 4. So when you substitute here in the above result, you will get f of x as 3 by 4, 4 by pi integral 0 to infinity sin omega minus omega cos omega by omega cube cos omega into 1 by 2, cos omega by 2 d omega, and this 4 by pi you take into the left hand side, you will get 3 pi by 16. So that is the answer to the question. Next one, find the Fourier transform of f of x equal to 1 in the interval mod x less than 1, so and equal to 0 elsewhere. So here also we have to find f cap omega. So the equation 1 by root of 2 pi integral minus infinity plus infinity f of x e raised to minus I omega x dx. So again substitute f of x equal to 1, we are getting e raised to minus I omega x dx, and integrate you get e raised to minus I omega x by I omega over the limit minus 1 to 1. So this minus I omega you taken to the with the 1 by root of 2 pi, it become minus 1 by root of 2 pi I omega, and when you given the upper limit it become e raised to minus I omega minus, when you given the lower limit, when you get I raised to I omega, and this and we have know that e raised to I minus I omega is cos omega minus I sin omega, and e raised to I omega is cos omega plus I sin omega. So when you subtract, you will get a 2I minus 2I sin omega, or you can do in this way, or we have already know that sin x equal to e raised to ix minus e raised to minus ix by 2I. So from that 2I sin x equal to e raised to ix minus e raised to minus ix. So e raised to ix minus e raised to minus ix, that form, of that form we have e raised to minus I omega minus e raised to I omega. So you can replace, very well replace that term with the 2I sin x, 2I sin omega, not x here, it is omega, okay, because e raised to I omega, so that it is 2I sin omega, and when you rearrange it you will get root of 2 by pi sin omega by omega. Then the next question is a KTU 2019 question. Find the Fourier transform of f of x equal to 1 minus mod x modulus of x less than or equal to 1 and equal to 0 for mod x greater than 1, and also find its inverse Fourier transform. So first we write the equation of a Fourier transform f cap omega equal to 1 by root of 2 pi integral minus infinity plus infinity f of x e raised to minus I omega x dx. And here 1 by root of 2 pi substitute f of x with 1 minus mod x e raised to minus I omega x dx. And here minus 1 to 1 we are splitting, since it is mod x value can be if it is of minus x or minus 1 to 0, mod x can be negative value, x can be negative value, and in the plus 1 to 0 it will, sorry minus 1 to 0 and 0 to 1 we are dividing into this minus 1 to 1 integration is dividing into two part, and in minus 1 to 0 x is negative, so this become 1 plus x e raised to minus I omega x, plus in 0 to 1 it is positive, so therefore x become positive, so 1 minus x e raised to minus I omega x dx. And then next step 1 by root of 2 pi 1 plus x into e raised to minus I omega x integrate e raised to minus I omega x by minus I omega minus 1 into derivative of the first part is 1 into integral of the second, plus second term or second integral also we can get the equation, and from this when you given the upper limit we have to add we have sum of two part, and in the first part when you given the upper limit 0 you will get the 1 by root of 2 pi 1 by minus I omega plus 1 by omega square, minus when you given the lower part minus 1 lower limit minus 1 you will get the second part, plus and the second integral also second part also when you given the limit you will get the second term. And here you have to replace with the one important thing you have to remember is that here there is first term is 1 by minus I omega, there you replace 1 with the minus I square because I square is minus 1, so 1 become minus of I square, so that change has been made in the equation. So whenever the denominator is I omega form, there in the numerator if it is 1 we have to replace with the minus I square, and then you rearrange, you are getting the answer as 1 by root of 2 pi 2 by omega square minus e raised to I omega plus e raised to minus I omega by omega square, which is equal to 1 by root of 2 pi 2 by omega square minus e raised to I omega plus e raised to minus I omega, that become 2 cos omega. How you get 2 cos omega? You substitute for e raised to I omega as cos omega plus I sin omega, and e raised to minus I omega as cos omega minus I sin omega, and when you add you will getting 2 cos omega. So 2 cos omega by omega square. So that become 1 by root of 2 pi, 2 is a common taken outside, 1 minus cos omega by omega square, and 1 minus cos omega and cos theta is 2 sin square theta by 2. So that with that you can return as 2 into sin square omega by 2 by omega square. So that is your f cap omega. Now if you want to find the inverse, so what is f of x? 1 by root of 2 pi integral minus infinity to plus infinity f cap omega e raised to I omega x d omega, and f cap omega is replaced with the above result root of 2 by pi 2 sin square omega by 2 by omega square e raised to I omega x. So that will become 1 by root of 2 pi and this root of 2 by pi into 2. So that become 2 by pi because 2 becomes root 2 into root 2. So 1 root 2 and outside root 2 cancels. So root 2 into root 2 becomes 2 and root pi into root pi becomes pi. So root 2 by pi sin square omega by 2 by omega square, again e raised to I omega x can be written as cos omega x plus I sin omega x. Now as previous we are dividing into two integrals, and the first integral sin square omega by 2, it is an even function because sin square means sin omega by 2 into sin omega by 2, so it becomes odd. Sin is actually an odd function, so sin square becomes an odd into odd becomes an even function. So even into cos omega is also an even function, but in the second case even into odd, so that becomes odd integral, it becomes 0. So it becomes 2 by pi first integral you can write as 2 times integral 0 to infinity sine square omega by 2 by omega square cos omega x dx. So it becomes 4 by pi integral 0 to infinity sine square omega by 2 by omega square cos omega x d omega. So from this, what is the integral value? Integral 0 to infinity sine square omega by 2 by omega square cos omega x dx d omega equal to 4 by divide f of x with the 4 by pi, so it becomes pi by 4 f of x. So now you replace pi by 4 in f of x. We have given us 1 minus mod x for mod x less than 1 and equal to 0 for mod x is greater than 1. And the last question is f of x, find the Fourier transform of e raised to minus x square. So here also f cap omega equal to 1 by root of 2 pi integral 0 to infinity e raised to minus x square into e raised to minus I omega x dx. And here 1 by root of 2 pi integral minus infinity plus infinity e raised to. Here also minus is common, you take it outside, x square plus I omega x dx. Now there is an adjustment, we are doing it 1 by root of 2 pi e raised to, because here when you here in the numerator in the exponential minus of x square plus I omega x, we are making it as a perfect square form, we are making an adjustment with the I omega by 2 whole square. So minus I omega by 2, that term you are adjusting. So that the part which you have underlined will become e raised to minus of x plus I omega by 2 the whole square. Okay, plus I omega by 2 the whole square become plus omega square by 4 dx, and 1 by root of 2 pi integral minus infinity plus infinity. Now you e raised to we are writing exponential in two terms. One is e raised to minus of x plus I omega by 2 whole square into e raised to minus omega by square by 4 dx, because minus is common to all. Okay, and then e raised to, when you integrate with respect to dx, e raised to minus omega by square by 4 is a constant term, so that you taken outside. So e raised to minus omega square by 4 divided by root of 2 pi integral minus infinity plus infinity e raised to minus of x plus I omega by 2 the whole square. Now we put x plus I omega by 2 as t. What is dx? Dx become dt. Dx become dt. So that become 1 e raised to minus I omega e raised to minus omega square by 4 divided by root of 2 pi integral minus infinity plus infinity e raised to minus t square dt. Okay, so that become, and we have e raised to minus x square dx, we have a standard result which is equal to root pi. Okay, so therefore it become e raised to minus omega square by 4 divided by root of 2 pi into root of pi. So when you cancels root pi, it become e raised to minus omega square by 4 divided by root 2.